Oh. All right, let's take a quick look at the last couple problems, and then I'll let you work. So we'll test tomorrow, Monday, then we'll move into some new stuff, okay? So, there you
You're
have
taking
it.
another test after this one?
We'll do, yeah, that'll be our final. So we'll do one over chapter, the one we're about to do, and then we're just gonna condense a few things into one last unit, and that'll be it, okay?
So we got chapter 7.
Well, it's unit 7, yeah, it'll be a combination, it's not hard stuff. It's not hard stuff. We're gonna do some solving radical equations. Now this is probably, we've done the hardest stuff. Units 5 and 6 would be the harder, those would be the hardest two probably. And then the next one's, it's not as bad. Okay, so let's have a look here. If we want to graph something like this, what are we gonna do?
So factor.
We're gonna factor,
Factor the bottom.
okay, and the top, right? So we'll factor this.
Yeah,
On the top, what can we do?
3x plus 2. Times x plus
Okay, on the bottom,
2. Minus 12.
yeah. X minus 6 and plus 4.
okay. Looks good.
Yep.
Okay, so based on that, what are the values of x that we have to exclude?
6 and 8, 4. Are you recording?
I am recording.
You got me a little nervous there.
Okay, so we have to exclude those. What's going on at those places?
Vertical asymptotes.
Okay, why are they vertical asymptotes and not holes?
Because they're not shared.
Okay, good, there's zeros at the bottom only. So we've got to exclude. Exclude those two, they're undefined. And we make sure we wrote vertical asymptote there, okay? Good? So we got vertical asymptotes, what about a horizontal asymptote?
No.
What do we do to find a horizontal asymptote? If it has horizontal asymptotes?
I have it in my
Be
notes.
something.
Just a sec.
So where horizontal asymptotes, that's gonna be end behavior stuff, right? That's
Oh,
when the
yeah, yeah,
function's
yeah, yeah.
approaching something out at the far right and the far left. So that's gonna be our, we're gonna take a limit, right? We're gonna see what happens as x approaches positive infinity or negative infinity. Okay?
It's not right. It's gonna be 0.
Okay, and yeah, what's our rule there? What's gonna happen in this case? What if the bottom polynomial is higher degree than the top?
It's gonna go up exponentially high. So it's gonna go to 0.
So the bottom, good, so if the bottom is stronger than the top, then it's gonna go to 0, isn't it? Right, because you're gonna get a bigger fraction on the bottom that goes to 0. And all we have to do, remember, is look at those leading terms, right? And if you don't even have to show this, but if you were to simplify that, 3x over x squared would just look like 3 over x, wouldn't it?
Yeah.
So you get 3 over some really big number, which is equal to
0.
0. Okay, so we get a horizontal asymptote. If we take the limit as x approaches negative infinity, the function goes to 0, right? Same thing up here. Okay, so we could say horizontal asymptote would be y equals 0. Okay? What would our vertical, if we wanted to write the equations of our vertical asymptotes, what would they be?
Wait, what?
It's like if I wanted to write the equations of these vertical asymptotes, what would they be?
X equals.
X equals -4 would be the vertical line, right? And this would be x equals 6. Okay, good. Any x-intercepts?
-2.
Okay, well, how come?
To 0 on the top.
Because it's a 0 on the top, but not the bottom, right?
Not the bottom.
Okay, so -2, 0 is an x-intercept. And that's pretty much all we need, right? Now we should be able to graph this thing. Okay, so here's a graph. Let's just see if this all makes sense.
Whoa.
Okay, so Okay, that makes sense, doesn't it? Here's our vertical asymptote at
What about the?
x equals -4. Here's another vertical asymptote at x equals 6. Here's our horizontal asymptote at y equals 0. There it is, right, on the x-axis. We've got our 1 x-intercept is there. And then all we'd have to do now is just check some test values, right? Check test values around each of these places. So we could pick values like -10, -3, 0, +10 maybe, and just check the sign of the function. Well, we want to look at the factored form, there it is, right? So if we check f of -10, we're going to get positive times times negative over negative times negative. Everybody get that?
Yeah.
How did you have an x-intercept here for the horizontal asymptote?
Okay, it's, the horizontal asymptote really doesn't tell us, good question, doesn't tell us anything about what happens in here. All it tells us about is what happens way over there and way over there. So I think where that's coming from is you're wondering if you can pass through an asymptote. And you cannot pass through a vertical asymptote, but you can pass through a horizontal asymptote or a slant asymptote. Okay, the only place they matter is way out there and way out there. Okay, they don't.
Any rational basis.
Sure. Yeah, but we can get this one. Once we know what the asymptotes are, we know where the x-intercept is, we just need to know, is the function above or below there, right? If it's below, it would have gone like that, right? If it's above, it has to go like that.
And the only way they're just gonna go through there is if there's more than one vertical asymptote, right?
Say it again?
The only way it's going through the horizontal one is if there's two vertical.
No, it could go through anyway. I mean, I could even have one, I could even have one like this, where if this is the x-axis, and that's the y-axis, and let's say we have a horizontal asymptote right there, I could have a function that even does something like this. It could be weird where it goes like that or something. It could.
Really?
Mm-hmm. It could.
Well, that doesn't make any sense.
I promise you it could. The horizontal asymptote just tells us what's happening way out at the tails of the function, just A and behavior. Doesn't really tell us anything about what's going on in here. Okay?
So what if it just squiggles infinitively?
Well, we'll get to that in calculus, because some functions do that. Okay, so we'll just check all these values. I'm maybe not going to check them all, but at least we'll check a couple just to remind you how that works. So if I plug -10 into my factored form, those are the signs of my factors. So what's the top? Positive times negative is
Negative.
divided by negative times negative.
Positive.
Negative over positive is
Negative.
negative, right? So we end up with, so we would know then that to the left of this asymptote, the function has to be below the x-axis, right? So that's all it can do. If it has to stick to that asymptote, and there's no x-intercepts out there, that's it. If it was above, it would have gone like that. Okay? If we check, between, at -3, let's just maybe check one more. If we check at -3, we're going to get positive times negative divided by negative
You got that one.
times positive, right? So I get, did I do that right? So I get negative on the top and negative on the bottom, and what's negative over negative? Positive. Okay, so there we get a positive, so we would know that between, at that point right there, at x equals negative, if we do -3, the function's got to be above the x-axis. Okay, get the idea? Okay, and we just do that for all those places. So if we check our point at 0, it would have told us it's going down. If we check the point at 10, it would have told us that it's going up. And so that's the only way we can draw this thing. Well, and once again, you don't even really have to be able to sketch the exact function. You just got to pick the one graph that fits all the criteria, the one that it could be, right? It would be, like, 5 choices that it can't be, and then there's the one that it can't be. You gotta pick that one, okay? Questions?
Next.
Okay, so then there's a bunch of questions like this. Or you got, I don't know, not a bunch. You might have 1 or 2 like this on the test. On your homework, you see a bunch like this.
Yeah.
So you don't even really have to graph this thing, you just have to know this stuff. You have to know what the domain is, what are the equations of the vertical asymptotes, where do the holes occur, and does it have any horizontal or slant asymptotes, and what are they? So we don't have to really sketch the whole thing, we
No
just
slant
need to know, what's the domain? Are there any values that x cannot be?
-1.
Are you sure? Look at the bottom. X
Oh.
squared plus 1.
2.
Is there any value of x that could cause the bottom to be 0?
No.
Now, how come?
Because it would have to be imaginary.
Have to be imaginary, right, because if I set the bottom,
Yeah, I see.
we know that x squared plus 1 cannot equal 0, which says x squared cannot equal -1. Well, that's no big deal, right, because that's impossible unless it's imaginary, and we only are looking for real values. So the domain of the function would be, and I think what they tell
All
you to
reals.
do is all reals. So you gotta pull down, you gotta go up to that menu and pull down that, there's like a weird script R that stands for the set of real numbers. It's just in one of the drop-down menus. Write the equations for any vertical asymptotes. There aren't any, right?
Yeah.
So we put n, I think n is what it tells you to put if there's nothing. Any holes?
Probably.
How come you're right? How come? There's no shared zeros. There's no zeros of the bottom, and so there can't be any holes, right? Can't be any holes or vertical asymptotes, so that one would be n. Horizontal or slant asymptotes. Well, we just gotta look at this. It's a rational function where the top and the bottom are the same degree. So what's our rule?
Then there's no slant
So what do we do? No.
asymptote.
No, does it have a, let me get hands, so I don't want people just saying it out loud, just let me get hands here, I'm gonna call in, so get some different people contributing here, so. Yes, sir,
It's gonna be 6/1.
6/1, okay, what's our rule for that?
There's.
If it's the same degree top and bottom, right, then we know that the horizontal asymptote, if we take the limit of this thing, it's gonna be the ratio of the leading coefficients, right, we've only got 3 rules. Let's real quickly, remember our 3 rules. If the bottom is a higher degree than the top, then we're gonna get a horizontal asymptote at 0, right? The bottom's higher degree, bigger power of x than the top, and we always know we're just gonna get y equals 0, right? When we take our limit, that's really what we're doing, is we're taking the limit of our function.
So if it's the same, it's just the ratio?
And because of this, because we get the same power of x, we're just looking at the ratio of the leading coefficients, right? 6x squared over 1x squared is just equal to 6. So we get a horizontal asymptote at y equals 6. If the bottom were higher degree, then we'd get 0. If the top is higher degree, then there are no horizontal asymptotes, but if it's 1 degree higher, we get slant asymptotes, right? Which is what we're looking at in this class, okay? Make sense?
So that's where x equals 6 or y equals 6? Y equals 6.
Y equals 6.
Yeah.
It's a horizontal asymptote, so it's a y equals something, horizontal line.
Easy. Next.
Okay. Okay, and that's just, I just wanted to remind you about. Oh, the thing I wanted to point out, so on this one, you gotta be careful, make sure you're reading through I made it blue, so it sticks out. If you have multiple values that are excluded from the domain on this kind of question, you have to add it like this, you have to enter it like this, you have to do it separately, like if there's 2 of them. If you have to exclude the values -2 and 3, you have to say x is not equal to 2, comma, x is not equal to 3. Okay, so make sure you just, you get that format now. Okay. What about this one? Same thing.
Factor.
Here we got a factor. So what are we getting on top? Show hands. We could do somebody different. Tanner's, he's gonna lose his voice. Yes, sir.
3, 6, x. That's code for.
Okay, what about the bottom? X minus 6, x plus 3, very good. Okay, so then what's our domain? We have to exclude what values?
6.
Okay? Any vertical asymptotes?
Yeah.
Which one?
6.
Okay, 6 is a exclusive zero at the bottom, right? It's not shared. So we'd say the equation of our vertical asymptote would be x equals 6, right? Okay, that's the vertical line. Holes would occur at what value? What's it gonna be? -3, how come?
If I haven't just raised my hand.
Shared zero.
Shared 0. Whoops, I already got the x equals. Okay, and then horizontal or slant asymptotes.
I thought it was -3.
It is negative, no, it's, yeah, -3, you're right. Horizontal or slant asymptotes. Now, what's our 0, how come?
3, 2.
Well, it's not the 3 terms on the bottom.
1.
What is it?
Oh.
What is it? Lily, can you tell us? How come we're getting 0 for our horizontal asymptote on this one?
You would get that x squared on the bottom.
Good, x squared on the bottom and an x on the top, so the bottom's more powerful, so we gotta get 0. Right, so we're getting y equals 0, okay?
That's what I meant.
There you go, okay? And then finally, one of these, last one, get you going. So we gotta factor it, right? Okay, tell me one thing to factor on the top, Tanner.
Negative.
Negative, pull out a negative. So I get negative, and then that's gonna leave me with what, x squared plus 4x plus 5, is that right?
X plus 5, X plus 1.
No, actually.
Oh, yeah. That's right.
Are there magic numbers on the
No,
top?
No.
Okay, so that's as far as we can factor it on the top, right? Okay, so then what's the domain, Kyle? X cannot equal what?
5. Or
Negative 5. Okay, good. -5. Julie, is that a vertical asymptote or a hole? It's vertical asymptote, good, because it's a 0 at the bottom only, right? So we get a vertical asymptote at x equals -5.
So if there's like no shared 0, like there's x plus 3 at the bottom, plus 3 at the top,
Then it would, if it's an x plus 3 on the bottom and the top, that'd be a hole at -3, because it's shared, right? Okay. Give me a handout here real quick. Holes occurring where? Where's it gonna be? Nowhere? Okay, good, because we only have one value where we have to exclude, and it's a vertical asymptote, so we get none. Now, here's the one we want to get to, last one.
Oh, yeah.
Okay, so are we gonna get a horizontal asymptote here? What do you think? Are we gonna get a horizontal asymptote here?
No.
Share the wealth here, Terry, somebody else have to try this. What do you think? No? Okay, how come?
Because the numerator is higher than
Okay, numerator's higher than the bottom, so we don't get a horizontal asymptote, right? What do we get here? Okay, because the top is 1 bigger than the bottom, right? So how do we find a slant asymptote? Yeah, we're gonna divide it out the easiest way, right? And then we'll take a limit, right? So if we divide this thing out, what is f of x? If I divide this out, what goes out in front? -5, okay. What are my coefficients?
1.
No?
-1. -4.
Okay, and then if we do this problem, do I get -1, 5, 1, -5, -10? Right, so f of x then,
-1.
if I divide it out, I get -1x plus 1 plus
Well, who cares?
-10, exactly, who cares, over my denominator, which was
X plus 5.
x plus 5. And if I take the limit of this whole thing, as x goes to plus or minus infinity, as x gets really big, what happens to that fraction?
It goes to 0.
It's gonna go to 0, isn't it? And it goes to 0 for the same reason that we got 0 for our horizontal asymptote here, right? Because the bottom is bigger than the top, okay? See that connection? So, oops. And so there's our slant asymptote, isn't it, right? So we get a slant asymptote at y equals negative x plus 1. That's it. Okay, make sense? All right, go.
Cool.